we are also going to find the domain of the functions in examples 1c and 1d. So in example 1c, our rational function is s of x is equal to 3x squared plus x over x squared plus 4. Okay, how do you find the domain of a rational function? You need to figure out the bad spots by setting the denominator equal to 0 to solve to get the bad spots. Okay, so let's do that. Okay, again, you don't have to pay attention to the numerator at all because there's no square root there. Okay, so for the bad spots, we are going to take x squared plus 4, set it equal to 0, and solve. Okay, so this is quadratic. There's a couple of ways you can do this. You can factor, you can use the quadratic formula. The easiest thing to do here is to just move the 4 over. Okay, that's going to tell you that x squared is equal to negative 4. Okay, you have something squared equal to a number. So the easiest thing to do here is to take the square root of both sides. Don't forget to put the plus or minus out front. All right, so if we simplify this, on the left, the square and the square root cancel, leaving you with x. And then on the right side, we have plus or minus the square root of negative 4. There's a negative sign under the square root. Okay, so remember what we've learned in the earlier parts of this chapter. That's negative 1 times 4 under the square root. So this is going to be plus or minus the square root of negative 1 times the square root of 4. So this is going to be plus or minus the square root of negative 1 is I. Square root of 4 is 2. So we end up with imaginary answers, plus or minus 2i. Okay, so these are imaginary. Okay, and we saw this back when we were in section 3.1. Okay, where we were trying to find the bad spots, we set the bottom equal to 0, and when we solved for x, we got an imaginary answer. Okay, so hopefully you remember what that means. Okay, this tells you you don't have any bad spots. Okay, because we tried to solve and we ran into an issue, we got an error. We got a negative under the square root sign. Okay, so this tells us there are no bad spots. Okay, and think about it. Whatever you plug in, positive, negative, or 0, you're going to end up squaring that number with the x squared. It's going to turn it positive or 0. So then you're going to add a positive number to it. So you're never going to get a 0 in the denominator. That makes sense. Okay, since there aren't any numbers that you can plug in for x to make you have a 0 denominator, there's no bad spots. The domain here is going to be all real numbers. Okay, you can plug in anything you want. You'll never get into trouble. Okay, all right, let's try one more. Okay, so in example 1D, we have the rational function t of x is equal to negative 2 times x squared minus 4. All of that is divided by 3 times x squared plus 4x plus 4. All right, so this one looks really complicated. Again, you're going to worry about the denominator. Take the denominator, set it equal to 0, and solve. Okay? All right, so here we go. To find our bad spots, we need to figure out when 3 times x squared plus 4x plus 4 is equal to 0. Okay? All right, so what's inside parentheses is quadratic, so we can factor or use the quadratic formula. This one factors really easily, so I'm going to go the factoring route, but feel free to use the quadratic formula if you want to. Notice this left side is kind of already factored. A 3 has been pulled outside of parentheses, so I'm going to keep the 3 out front, and then I'm going to try to break down what's in parentheses. I'm going to try to factor that. Okay, so x squared is going to break down into x times x, and then 4 breaks down into 2 times 2, and then both of the signs are positive, so I'm going to keep positive signs here, and let's check to make sure this is how it factors. Okay, so if we multiply it back out, if we did the box method here, if we did x plus 2 times x plus 2, we should get what we started with. X times x is x squared, x times 2 is 2x, 2 times x is 2x, 2 times 2 is 4. So if you do this, you're going to get x squared. Combine like terms, 2x plus 2x is 4x. and then plus 4. That is indeed what we started with in parentheses, so we have factored correctly. Okay? All right, so now that we've factored, we need to take each factor, each of the things that we're multiplying together, set it equal to 0, and solve to get our bad spots. Okay? If you first take the 3 and set it equal to 0, there's no x. And this doesn't even make any sense. The number 3 never equals the number 0. Okay, so we've seen something like this before. Okay, if your factor is just a number, you ignore it. Okay, you only take the factors that contain a variable and set that equal to 0. Okay, so the other two factors are both x plus 2. They're the same factor, so you only need to set it equal to 0 once, because they're going to produce the same thing. So if we solve for x here, our bad spot is x equals -2. Okay, so the domain is going to be all real numbers, except x equals -2. You only have one bad spot. So let's go ahead and draw this out on a number line. So here's our number line. Okay, we're going to put our lone bad spot here at -2. Put an open circle to exclude it. Every other x value is good, including decimals and fractions. And we'll go from left to write down the interval notation. Okay, so if you're over here on the left, you're at -infinity, and then you fall in the hole at -2. -2 is bad, so we want to exclude it with a parentheses. We dig out of the hole on the other side of -2. We're still excluding it, so we need a parentheses, and then we walk off to +infinity. Okay, so here is your domain, all real numbers except for -2. Okay, so just keep in mind how you need to find the domain of a rational function. You need to concentrate on the denominator. As long as there's not a square root or something like that in your numerator, you can only just solely focus on the denominator. Set it equal to 0 to get your bad spots, and then your domain is going to be all real numbers except for the bad spots.